And good morning, fourth graders. Welcome to room 502. Your room, my room, our room. Time for some Eureka math. And what does Eureka mean? When translated into the English language, it means I have found it. And what have we found? We have found the best way in the world to learn math. And that, my friends, is more valuable than gold itself. Let's take a look. There were 3,905 more hits on the school's website in January than in February. Sorry, this is last night's homework. You're going to need that out. Pause the video if need be. February had 9,854 hits. How many hits did the school's website have in both months? Okay, so there were 3,905 more hits on the school's website in January than February. We know February had 9,854 hits. So we're going to make it look like this. I'm going to put February first. And how many hits did we get on that website in February? Let's take a look back. 9,854. And in January, we had more than in February. So we had this amount, 854, excuse me, plus 3,905 more. What do we need to find out? We need to find out about how many hits did this website have during January and February. So about. The key word means this is rounding, ladies and gentlemen. Let's round to the nearest, let's round to the nearest 10,000. So that means the 9 and the 3. They may change, they may not. Think about it, 9,854. Is it closer to 9,000 or 10,000? Excuse me, we're rounding to the nearest 1,000. Excuse me, Mr. Leggett, not 10,000. So is it closer to 9,000 or 10,000? Well, it's 9,854. We know that's above the midpoint of 500 when we're dealing with thousands. So we would round up to 10,000. Over here, the same thing, 3,905 is going to be closer to 3,000 or 4,000. Well, look, we're already at 3,900. That's way above the midpoint of 500. So we'd round up to 4,000. And we would get 0, 0, 0, 14, and 14,000. So the website had about 14,000 hits for January and February. We could write that too. Let's go down and do B. See if our answer is reasonable. And it says exactly how many hits did the website have during January and February. So we're going to have to do a little bit of adding. 3 digits. Remember we have to add the 9,854, the 3,905, and we're going to have to add this twice because this in January is 9,854, right? So 3-digit addition. I'm going to break this apart a little bit. I'm going to add the 9,854 plus 9,854, and then we'll deal about the 3,905 later on. So 4 plus 4 is 8, 5 plus 5, or 5 times 2 is 10, 8 plus 8 is 16, plus that 1 is 17. Remember the trick we talked about yesterday? 9 plus 1 is 9, plus 9 would be 19. 9 plus 1 is 10, plus the 9 would be 19. So now we have 19,708, and we're going to add on the more in January, which was 3,905. Let's do a little addition. 8 plus 5, that's 8, 9, 10, 11, 12, 13. Bring my 1 there, 13. 0 plus 1 is 1. 9 plus 7, 16. Bring the 1 over here. Once again, 9 plus 1 is 10, plus the 3 would be 13. And another 1 goes over here, 1, 2. So the website got exactly 23,613 hits in January and February. Let's move on today. Today. You can put that in the homework bin, the homework drawer. Look for the homework drawer. I just labeled it. So pause and go turn that in before you forget. And we'll go to our objective, is to use place value understanding to decompose to smaller units using the standard subtraction algorithm. And we're going to apply the algorithm to solve word problems using My favorite, tape diagrams. But first we're going to subtract some common units. Oh, they're common, all right. Let's start subtracting common units. Let's say the number is 707. We could say that, what does this consist of? Say the number in unit form. We'll say it in uniform. 7 hundredths, 7 ones. Okay, so we have 700, 7 ones. Let's subtract 202. Now what do we have? 2 hundredths and 2 ones. Yes, but don't use the word and. We have 2 hundredths, 2 ones. How do you like that? So now we could do a little subtraction here, boys and girls, ladies and gentlemen, dames y caballeros. Simple as can be. What's 7 minus 2? That would be 5 hundredths. 7 minus 2, ones, 5 ones. What is our answer? It's 505 ones, 505. Formula 505. Let's do another one for fun. And this one will be 909 minus 404. What will that equal? Well, let's do this trick right here. How many hundredths, how many ones? 9 hundredths. And I'm just going to use an H. I don't want to spell that out. And 7 ones. We know what those mean by now. And what are we going to subtract? 4 hundredths and 4 ones. So 4 hundredths, 4 ones, not 40, that's 4 ones. Do the math. 9 minus 4, what do we get? Excuse me. 7 minus 4. 3 ones, 9 minus 4, 5 hundredths. So we would get 5 hundredths and, well, not and, 3 ones. Continue on. We're going to try this one. Going to go to the thousands. 9,009 minus 5,005. So we have 9 thousands and 9 ones. Over here, we're going to subtract the 5 thousands and 5 ones. What do we get? 9 minus 5 is 4. 4 ones. 9 minus 5, 9 thousandths minus 5 thousandths is 4 thousandths. It looks like we get 4,004. There you have it. We'll continue on over here. And let's do 11,011 minus 4,004. Okay, so how many thousands do we have? We have 11 thousands, okay? So I'm going to write 11 thousands, and we have 11 ones. 11 ones. We're minusing 4 thousands and 4 ones. And so 11 minus 4 ones, 11 minus 4 would be 7, right? Whoops, I don't put the 0 there. There's our ones. And 11 minus 4 would be 7 thousandths. 11 thousandths minus 4 thousandths. Our answer is 7,007. We've got enough room to squeeze that in there. Welcome aboard to the next problem. Are we ready? It's 13 thousands, 13 ones. Okay, so it would look like this in standard form. 13,000, 13 ones. And we're going to subtract 8 thousands and 8 ones. So let's do that. 8 thousands minus 8 ones. And 13 minus 8 is 5. 13 minus 8 is 5. So there we go. 5,000, 5 ones. So this would equal 5,000, 5 ones. All right? It's going to help us with our lesson today, believe it or not. Let's continue on to our application problem. Find out what's going on with a gal named Jennifer. Jennifer texted 5,849 times in January. She loves to text. In February, she texted 1,263 more times than in January. So, gonna mail that, gonna circle that, I mean. We're asking what was the total number of texts that Jennifer sent in the 2 months combined. We need to explain how to know if the answer is reasonable. Let's get started on this. So we're going to start off with January. And January was, let's make our tape diagram. January was 5,849. We go to February, and in February it said it was 1,263 more times. So we make our tape diagram. This is the same amount as this one up there, but she's texted an additional 1,263 times. So now our problem's pretty much set up. All right. First thing we're going to do is let's round to the nearest 1,000. So we have this number, remember, is the same as the one on top, 5,849. Nearest 1,000, what do we round 5,849? Is it closer to 5,000 or 6,000? Well, 5,800 is larger than 5,500, so it's closer to 6,000. So we're going to make two 6,000s, and Mr. Lake is going to put little checks right there to remember. And how about the 1,263? Is that closer to 2,000 or 1,000? Well, we can see that it's below the 1,500 or 1,500 mark. This is less than, so we would have to give it 1,000. And we had two 6,000s. Yikes. Sorry, guys. Sorry, kiddos. Let's make it two 6,000s up here, right? 6,000 once, 6,000 twice, and 1,000. It's going to come out to 0, 0, 0. What's 6 plus 6, or 6 times 2 is 12, plus the 1 is 13. So that is our estimate. That's a plus sign. Wow. So that's our estimate. Let's find the real totals, okay? So let's go ahead and do that. And let's add February first, and then we'll add January. So February, we'll set up the problem like this, 5,849 plus 1,263. And what I'd like you to do is pause the video and work this problem out on your own. Welcome back. Hope you got the problem right. Let's find out. 9 plus 3, it's 12, right? Then we put our 1 right there. So there's the 12. 6 plus 4 is 10, plus 1 is 11. Put our 1 right there. See, there's the 10, there's the 1, 11. So we do 8 hundredths plus 2 hundredths is 10 hundredths, plus the 1 would be 11 hundredths, which would be 100 and 1,000. And then 5,000 plus 1,000 is 6,000, plus the other one is 7,000. So you have 7,112. But now we need to take this number and add on January. And remember, if you look at your notes, January was 5,849. Okay, so go ahead and pause the tape and work this out on your own. I know you can do it. Welcome back. 2 plus 9, well, that's 11. 2 ones plus 9 ones. Now we have 1 10 plus 4 tens plus 1 10. That's 60. No need to bring over anything. 8 hundredths plus 1 hundredths is 9 hundredths, right? And then 7 plus 5,000. 7 thousandths plus 5,000, 7. 8, 9, 10, 11, 12, right? There we go. And we're 12,961. So let's go back to our estimate, and we can see, by golly, that these two numbers are pretty darn close to one another. So we can say that, let's do it. Let's make here my answer for writing. RDW is reasonable. The estimate is only, want to put the actual number? Why not? 39 more than the actual. And that's doing my math in my head there. And finally, we need to write about how many texts she sent. Jennifer sent 12,961 texts in January and February. Oh, there we go. She's a texting machine. All right, ladies and gentlemen, boys and girls, damas and caballeros, what we're going to do is we're going to put this aside. We're not doing this problem yet. What we will be working with is the fabulous, wonderful scratch paper packet. And those are the 3 pieces of paper that you have, no doubt, stapled together. And what we're going to do is use this to finish up our concept development. So let's get busy right away. And I'm going to zoom out so that we can see the whole piece of paper, or most of it. There we go, that's pretty darn close. Okie doke, here we go. So our first problem of the day is 4,259 minus 2,171. Now, watch and do the tape or diagram with me. So here we go. Now, I'm going to model the whole, 4,259, okay? Then we'll have an unknown part, all right? So here we go. Really try to grasp your heads or wrap your heads around this. This tape represents this number right here. The whole. 4,259. But what we're doing is we're subtracting from it. How much? 2,171. Okay? What we don't know is this. What's this? We don't know. So we're going to try to figure this out, all right? So first, let's make a place a value chart. We're dealing with thousands. It's not going to get larger, right? We're subtracting. It's going to get smaller. So I'm only going to make a place value chart that has my thousands, hundreds, tens, and ones. Ones, tens, hundreds, thousands. So let's start creating the 4,259. We have 9 ones. Okay. How many tens? 5, right? 1, 2, 3, 4, 5. How many hundreds? Well, we have 2. And how many thousands? We have 4. Okay? 4,259. 4,000s, 200s, 5 tens, 9 ones. It's time to start subtracting. So, can we subtract 1 from 9? Yes! That means we're ready to subtract in the ones column. Okay? So let's go ahead and take 1 away. Ah! That guy got it. Alrighty. Let's take a look at the tens column. Are there enough tens in the top number to subtract the tens in the bottom number? So let's go over here. We're going to set this up as a standard algorithm. 4, 2, 5, 9, 2,171. So yeah, we just did 9 minus 1. What did that give us? 1, 2, 3, 4, 5, 6, 7, 8. But here's our problem. What do we do there? Ay, 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 que lastima. What do we do? Well, we need to do some regrouping. We're going to regroup or unbundle 1 unit from the hundreds to make 10 tens. All right? We ready to do this? Let's make 10 tens from one of these hundreds. Yikes! There he goes. And now watch this. Here he comes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Look at all. There's the 100, became 10 tens. And now it looks like I have 15 tens, right? But how do we show that in the standard algorithm? Watch. We had 200s. 200s there. They became 100, right? I crossed 1 out. But they gave 10 tens to that 5 tens to make 15 tens. Okay? Or 150. Let's subtract 7 tens. 1, 2, 3, 4, 5, 6, 7. How many do we have left? Excuse me. 1, 2, 3, 4, 5, 6, 7, 8 are 80. So we can do that just fine. Let's continue on to the 1 minus 1. What do I got to do there? Look, take away 1 from the hundreds. I'm left with 0. Now it's just a matter of 4 minus 2. 4 thousandths minus 2 thousandths is 2 thousandths. And look, it works out perfectly. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 0 and 2. So there's our answer, 2088. So this number equals 2088. And we could put, I kind of like doing this. Let's put 2088 in there to show that 2,171 plus 2,088 would equal 4,259. Let's do another one, get rolling on that. Excuse me. And we're going to come here, we're going to do the same thing, tape diagram and place value chart with 6,314 minus 2,100, excuse me, I'm looking at the old one, minus 3,133. Let's get busy on this. We'll do our tape diagram first. Remember, this represents the whole. And what's the whole? The whole is 6,314. What we do know is what we are subtracting. What we're subtracting is as follows. 3,133. What we don't know is the answer to this. What is that all about? How are we going to figure it out? We're going to use the one and only fabulous place value chart. Remember, we're just dealing with thousands, and they're going to get smaller. So thousands, hundreds, tens, und ones. And I'll make my standard algorithm over here. Okay, so we have our ones, tens, hundreds, thousands. Okay, we're all set there, right, boys and girls, damas y caballeros, ladies and gentlemen? Let's set it up. Let's set up our number first. 4 thousands, 5, 6 thousands, excuse me. It's 6,314. 3 hundreds, 110, 4 ones. Now I like to use this football terminology. Can we tackle the 3 ones? Can we make that happen? Sure. 4 minus 3. What are we left with? We're left with number 1. That's all we got left. Okay, so we have a 1 here. We're done. That ones column finished. Gone. Done. But we have the tens here. Can I take away 3 tens from 1 tens? Now, a lot of students in my past have said, oh yeah, 3 minus 1 is 2. No, not going to happen. Not going to work. This is 1 10, that's 3 tens. You can't take 30 away from 10. We need to borrow, or what we call rebundle. Rebundle. We're going to do some rebundling. Are you ready to rebundle? Let's rebundle. How do we do that? We take this 100 over here and we say, we need your help. I'm 10. I need help, Mr. 100. We'll all send over 10 tens for you. And this guy gets crossed out. And over here he goes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Look at that. He said, I've sacrificed one of my hundreds, and now I'm only 200s. However, I gave 10 tens, or 100, to my good buddy over next door to me, so that he becomes 11 tens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 tens are 110. Now, we are going to subtract 3 of them. Ready? 1, 2, 3, and now let's count how many we got. 1, 2, 3, 4, 5, 6, 7, 8. So 11 minus 3 must be, ding, 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 8. Let's go over here. We have 200s minus 100. Easy enough. There's my 200s. Say goodbye. Left with 100. And I'll put my 8 right there and my 1 right there. Now we're left with 1,000s. 6,000s minus 3,000s. Hey, no big deal. We got enough to go around, and we subtract that, and we have 3 left, and we have 3 over here. So the answer is 3,181 right there. Look, it works out perfectly. I love this math. One of my favorites. All right. So now let's go to scratch paper on number 3. Can you believe how much scratch paper I have? Oh, is that scratch paper? Oh, it's a mess if it is. Yeah, here we go. So find the next page on your sketch keeper picky. And we'll put 23,422 minus 11,510. That's a 5. So here we go. Let's make a tape diagrammy. Remember, we got to do the whole first. What's the whole here? WHOLE. 23,422, amigos. All right, and what else do we know? We know how much we're subtracting. We're getting rid of, we're getting rid of 11,510 of these guys. What we don't know is the answer. All right, let's talk about this. And we're not going to use the place value chart. So we're really going to have to be on top of things, okay? Sometimes I can't subtract like that. I've got to stack them. So let's stack them. Stack them up, stack them up. Stackers. All right, so we can do this. I know you can. You've just got to work slowly and carefully. Try it on your own. If you're confused, follow along with me, okay? 2 minus 0, what is that? It's 2. 2 minus 1, what is that? 2 take away 1 is 1. Can I take 5 from 4? No, but I know some of you will, and it'll aggravate me. I hope you don't. We'll say 5 minus 4 is 1. No, that's not the case. You can't take 500 away from 400. You have to rebundle. Well, not rebundle. We have to decompose, we call it borrow. We say, hey, 1,000, I need 10 hundredths. He says, okay, there you go. He becomes a 2 because he's given 1,000 to that 400. So now he's 14 hundredths. Now we can subtract. 14 minus 9, or 5 is 9. Little comma there. Now look, it's easy. 2 take away 1, 1, 2 take 1, 1. There's our answer, 11,912. All righty. Let's give it another shot. And let's try this one. We'll go to another piece of scratch paper. I hope I have one more left. I think I do. And let's do 29,014 minus 7,503. So our whole. Is 29,014. What we know is the subtraction is 7. Whoops. I always want to put it in the tape diagram. 7,503. There we go. So our problem's all set up. What we don't know is the answer. Because believe it or not, after we subtract, if we add these two numbers together, we get the whole. It's true. It's true. Let's keep going on, though, boys and girls, ladies and gentlemen, damas and caballeros. Mr. Leggett is going to do it a little more Eureka style. Sometimes I get going so fast I forget to do it Eureka style. So here we go. We're going to do 29,000. Stack these bad boys up. Minus 7,503. So what's 4 ones minus 3 ones? Well, if I had 4 apples and Johnny stole 3, I'd be left with 1 apple. All right, 1 take away 0. 1 take away 0 is 1. Can I take 5 away from 0, 5 hundredths away from 0 hundredths? Yes, you can do that. I'm the math dictator, and I say you can. Well, math dictator, you've steered me wrong many times before. We can't take 5 hundredths away from 0 hundredths. Yes, it would be 5. 5 take away 0 is 5. Yes, but how do you explain 0 hundredths minus 5 hundredths? It can't be done. Oh, if I say it can be done, it can be done. Well, just because you're the math dictator doesn't mean you can break the rules of math. Oh, I can do what I like. No, you can't. You cannot take 5 hundredths away from 0 hundredths. So I'm going to ask you to please leave my math video because you're going to confuse people. Because kids already get confused. They go subtract this way when it can't be done. But it can be done, I tell you. Yeah, sure. No, get out of here. That guy drives me crazy. He thinks he can just make up rules of math. Math has very set rules that we need to follow. He doesn't care about the rules. He always thinks he's right. So we can't take away 5 from 0, so we have to borrow again. And watch, this is the Eureka way. The 9 becomes an 8, right? And then there's the 0. We're going to cross out that 0, and we're just going to put a 10 on top. You see how that worked? We took 1,000, our 10 hundredths, and brought them over here. So that became 8,000s, that became 10 hundredths. Now 10 take away 5, halfway, we all know that, it's 5. 8 minus 7 is 1, and drop down the 2, and our answer is 21,511. Isn't this kind of interesting the way to do this? You know, I really like doing the tape diagram too. I think that really helps us visualize all this. All right, we're going to return back to our math packet for this paper. All right, we got to annotate it. That's the Avid way. We annotate it, even math. People say, well, but I thought Avid only annotated reading. And I say, no, good sir. You're wrong. In Avid, we annotate math as well. Advancement via individual determination. So let's tackle this problem in a determined yet focused manner. Okay, the Strands paper mill produced 73,658 boxes of paper. And that's a lot of boxes. So let's go ahead and circle 73,658. And let's see what happens here. 8,052 boxes, they've been sold. They're out the door. They're making money for Strands paper mill. What we need to find out is how many boxes remain at the Strands paper mill. Because we might be all panicky. We might have too many boxes sitting there. We say we might have to cut the cost of our boxes. We got to get these boxes out of our warehouse.